The next section is called Inequalities and Triangles. Now let's review real quick. What's an inequality? What's an example of an inequality? That's an inequality, right? Greater than, less than, greater than or equal to, less than or equal to. Right? So we're going to be working with inequalities and triangles and talking about which sides are bigger than what sides of a triangle, which angles are bigger than what angles, and we have these theorems to help us. Now, if you have your postulate sheet, there's 3 theorems from this section, and all 3 of them we use quite a bit. Okay, so if you have that out, that might be helpful. Before that, we need to recall what an exterior and remote interior angles are. So if I had a figure like this, of course, what's the exterior angle in this figure? 1, right? 1's the exterior angle. We have 3 interior angles, 2, 3, and 4. Okay? And then we have 2 specific type of interior angles called remote interior angles. This was from last section, before break. Which are the 2 remote interior angles in this figure? Everybody remember that? 3 and 4, right? And what we mean by remote, if something's remote, like remote desert island, it's off by itself, right? So we call these remote interior angles because they're off by themselves kind of compared to this angle 1. Right? They're not beside this angle 1. These 2 are a linear pair. Right? Those 2 add to 180. But these are called remote interior. So it's just a specific type of interior. And why that's useful is because we have a theorem that says angle 1 is equal to angle 3 plus angle 4. Right? That was a theorem from last section. The outside angle, the exterior angle is equal to the 2 remote interior angles added together. And you want to know that theorem because the first theorem in this chapter is called the exterior angle inequality. So now instead of equals, we're talking about inequalities. And what that says is it says, well, if angle 1 is equal to 3 and 4 added together, then that means it has to be greater than both of those angles separately. Right? So if I know this, the exterior angle inequality says the measure of angle 1 is greater than the measure of angle 3 by itself, and it's also greater than the measure of angle 4 by itself. Right? Which that makes sense, because if the previous chapter told us it's equal to those 2 added together, it's got to be bigger than both of those separately. So without knowing any angles of this triangle, you can tell me 1 is automatically bigger than 3 and 4. Now it obviously looks like it, but you can't go off anything on looks here. You wouldn't be able to prove this. I can't say 1's bigger than 3 just because it looks like it, because it might not be drawn to scale. But I can say 1 is bigger than 3 by what we call this exterior angle inequality theorem. It means the exterior angle of a triangle is greater than each of the 2 remote interior angles separately. And even though 1 looks greater than 2 here, I can't prove that by this theorem. Okay? I know these 2 together add to 180, but without knowing one of them, I can't find the other. Okay? So this is this first theorem. It's 5.8, the exterior angle inequality. So without knowing any angles in this figure, you don't know any, well, sorry, I'm going to give you one. You know this is 90. Other than that, you can find out which angle here is the biggest without knowing any others. Again, we know which ones look the biggest, but that's not good enough. You can't just say this looks like it's bigger, so it's bigger. Okay? We know if we look at this triangle, 1's the exterior angle, which is the 2 remote interior angles. 4 and 3, right? Everybody agree with that? So I know by that theorem. So we're looking at the exterior angle inequality theorem, right? And first let's look at this angle 1. So it's the exterior angle. What are the 2 remote interior angles here then? 4 and 3, right? So automatically I can say angle 1 is bigger than angle 3 and it's bigger than angle 4. Because I know it's actually equal to those 2 put together. Now again, don't confuse these. These are angle symbols. These are inequalities, okay? So I know it's bigger than 3 and 4, okay? Because it's equal to those 2 put together. Then let's look at the other way. 5 is the exterior angle. What are the 2 remote interior angles here? 2 and 3, right? So I know 5 is bigger than 3, and angle 5 is bigger than 2. Okay. So, yeah, sorry, I messed that one up. 5's bigger than 3, and 5's bigger than 2. Okay? Well, how many degrees is angle 5? 90. It's got to be 90 because it makes a straight line with that one, right? And I know if 1 is bigger than 4, and those are both 90, 1 is also bigger than 5. Everybody agree with that? Right? Because it's the same. 4 and 5 are the same. So I know 5's bigger than both of those two. So then I know, well, 1's bigger than 5, and 5's bigger than 2. So 1's got to also be bigger than 2. So the largest angle in this figure is angle 1, and I could find that without knowing anything other than that's a 90-degree angle. Okay? I don't know how many degrees any of them are, but I know 1 would be the largest in this figure by just using that theorem. Does that make sense? So let's look at this figure first. Angle's less than angle 1, so here's an exterior angle. Now, I actually have two different triangles I can look at here. If we just look at this little one, okay, 1's the exterior angle. What are the two remote interior angles? 3 and 7, right? So it's got to be bigger than 3 and 7. So angle 3 will be in that list. Angle 7 will be in that list because it's equal to both those added together. If you look at this large triangle, 1's still the exterior angle. What are the two remote interior angles here? Be careful. I'd agree 5 is one of them, right? The other one is this entire angle right there, right? It's 6 and 7 put together. So 1 is actually bigger than 5, and it's bigger than 6 and 7 put together. So that means it's got to be bigger than 6, right? So I can add 5 and 6 to this list. Another way I could do it, well, if I look at this triangle, 3's the exterior angle. What's the two remote interior angles here? If 3's the exterior. 6 and 5, right? So I know 3's bigger than 6 and 5. And if I already know 1's bigger than 3, 1's got to be larger than 6 and 5. And I already had 5 in my list. So just by using that same theorem, I can say angle 1 is bigger than all of these angles without knowing any of the degrees. Okay? You know, you could say, 8 is bigger than 4 and 6, but that doesn't help you anywhere, right? That doesn't compare 1 to any of these. I was just looking for angles less than 1. So this theorem kind of makes sense here. The exterior angle is bigger than the two remote interior angles. Okay, in this figure, I'm looking at angle 16. I want angles less than that angle. So let's first just look at this small triangle. It's the exterior angle. What are the two remote interior? 2 and 10. So I know it's bigger than both 2 and 10. So I can add angle 2, angle 10. If I look at this larger triangle, it's the exterior angle. What are the two remote interior? 8 and 1 and 2 put together, right? If I'm looking at this triangle. So I can add 8, 1, and 2 to that list. I already have 1 and 2, so I will just add 8. Yeah. That's really it. That's the only two triangles. That's not it for the problem, but that's it for this exterior angle, this triangle and this bigger one. Okay. Well, now let's look. I know it's bigger than 2. Well, 2's not the exterior to any. I know it's bigger than 1. 1's not the exterior. I know it's bigger than 8. 8's not the exterior to any. Okay. So 2, 1, and 8. Yeah, sorry. 16 in this one. That triangle, 2 and 10. I didn't list that one. We said it, but I didn't list it. There you go, 10. Okay. So 10's on that list. So now let's look. 10 is also the exterior angle. Let's look at this triangle. 10 is bigger than which two? 4 and 5. Right? It's the exterior angle, these two remote to interior. So I know 16 is bigger than 10. I know 10 is bigger than 4 and 5. So 16 has to be bigger than 4 and 5. Okay. So I'm going to add 4 and 5 to that list. Let's look the other direction. 10 is the exterior angle. It's bigger than two remote interior, which are which two? 1 and 8. Those are already on my list, so I have that taken care of. There's actually one more here. Okay. There's one more that I can add to that list. Anybody know it? Which angle would be the same as angle 10 in this figure? Again, you know none of the degree measures here. 12 would be the same. Why? because they're vertical. 10 and 12 are vertical. These are the same angles. So if 16 is bigger than 10, I can also add 12 to that list. And there's all the angles bigger than 16. 5.9 says if one side of a triangle is longer than another side, then the angle opposite that side is greater. So I don't know any angles in this figure, but I can tell you which one is the largest. Okay? Well, first I just look at the largest side. The largest side is 12, right? So this theorem says the angle that's largest is always opposite the largest side. Which angle is opposite this largest side? A, B, or C? B, right? So I would say this is the largest angle in this figure because it's opposite the largest side. And you can actually work backwards now and tell me what the second largest is and what the smallest is. What do you think the smallest angle would be here? It'd be C, right? Because that's opposite the shortest side. So this would be the smallest angle. And this would be in between those two. Again, without knowing any of the degree measures. You can compare which angles are largest. And then the last theorem is just the converse of that. It says if one triangle has an angle greater than another, then the side opposite that is larger. So similar figure. If I tell you these degree measures, and I said this one is 80, this one is 30, and this one is 70, and asked you which side is the largest side, which side would be largest? BC, right? It's always opposite. Which that makes sense, right? If you have an angle that opens up really wide, and it's got a huge angle, the side opposite that is going to be huge too, right? So this would be the largest side, which would be the next biggest. AB, right? That would be the second, and this would be smallest. So those two things are very easy, just comparing angles and sides. Whatever side's the largest is always opposite the largest angle and vice versa. Okay.